Is Malaysia ready for the Spintronics wave by AZLAN ADNAN MA Monday, 8th of December 2025 introduction. Spintronics is set to redefine global electronics, promising faster, cooler, and vastly more energy-efficient devices. The question now is whether Malaysia's semiconductor industry, long a backbone of the nation's export economy, is positioned to seize this emerging opportunity. Malaysia's existing semiconductor strengths. Malaysia already commands a strong foothold in back-end assembly, packaging, and testing. Penang alone hosts hundreds of multinational suppliers tightly integrated into global supply chains. These strengths give the country a practical starting point. Spintronic devices, especially MRAM and advanced sensors, will still rely on high-precision back-end processes. The challenge of front-end fabrication. However, the most valuable parts of Spintronics, materials engineering, thin film deposition, and quantum-scale fabrication, sit firmly in front-end manufacturing. Malaysia currently lacks large-scale commercial fabs capable of producing next-generation MRAM or spin logic wafers. Bridging this gap requires significant capital investment and deep R&D capabilities. Without them, Malaysia risks remaining a low-value player in a high-value future market. Emerging opportunities in materials and equipment. Spintronics relies on exotic materials such as magnetic multilayers, topological insulators, and spin-orbit torque structures. Malaysia's growing ecosystem of specialty chemical firms and equipment suppliers could move into these niches. With governmental incentives, local firms could position themselves as key suppliers to global fabs. This would mirror Malaysia's earlier rise as a preferred partner in test equipment and automation. MRAM and sensor modules, a natural entry point. Early commercial Spintronic products, MRAM modules, and high-sensitivity sensors require sophisticated packaging and reliability testing. These align closely with Malaysia's existing strengths. If local manufacturers upgrade capabilities to handle magnetic shielding, ultra-low noise packaging, and specialized reliability regimes, Malaysia could capture early market share. This approach offers a realistic near-term path without building billion-dollar fabs from scratch. The talent and research question. Malaysia hosts several research groups working on nanomagnetics, 2D materials, and quantum devices. But coordination between universities and industry is still limited. A national Spintronics research consortium could accelerate technology transfer, attract foreign partners, and build specialized talent pipelines. Countries that dominate new semiconductor waves always invest early in skills, not just factories. Government support and national strategy. The new Industrial Master Plan and the push for higher value semiconductor participation signal the right direction. But policy must move faster if Malaysia hopes to compete with Taiwan, Korea, or Singapore in emerging Spintronic markets. Targeted incentives for pilot lines, materials R&D, and advanced packaging would help Malaysia climb the value chain. Public-private partnerships could de-risk early investment and attract global Spintronics players. Overall outlook. Promising but not guaranteed. Malaysia is not yet a full-stack Spintronics powerhouse, but it has enough strengths in packaging, testing, automation, and supply chain reliability to carve out a meaningful position. If the nation upgrades its capabilities, nurtures specialized talent, and aligns policy with global trends, it can capture significant value from the coming Spintronics wave. The window is open, but it will not remain open for long. Learn to cook with confidence. A holiday cooking experience for teens and school leavers. Cooking is one of the most important life skills a young person can develop. We eat every day, and knowing how to prepare good food sets you up for independence, creativity, and lifelong well-being. In my holiday cooking classes, I go far beyond teaching recipes. I blend knife skills with the wonders of food science, the chemistry, biochemistry, and nutrition that shape every flavor, texture, and aroma. It's the practical, delicious side of the science you learn at school. My sessions are fully hands-on. You will feel the warmth rising from a pan, hear onions sizzling into sweetness, smell butter turning nutty and golden, and watch simple ingredients transform into something extraordinary. Cooking becomes a sensory adventure, not a chore. To ensure every student gets dedicated attention, I keep each class small, just 3 to 6 participants. We learn by doing. We taste constantly. We experiment with confidence, and we uncover why small changes in technique make big differences on the plate. Classes are held by appointment throughout the December school holidays. Each session gently builds confidence, skill, and curiosity as students work from raw ingredients to a finished dish they can proudly serve at home. And here's something parents love. My class fees are by donation. If your child walks away bored or unmoved, you pay nothing. But if your child returns home excited, inspired, and perhaps presents you with a classic French onion soup, richly caramelized and impossibly fragrant, then simply contribute what you think that experience is worth. If your child keeps pestering you to bring them back for more classes, well, you'll know you've got your money's worth. All proceeds help fund my ongoing eye treatments, so every contribution goes to good use. Students will also learn how to choose fresh ingredients and shop smart. Do give them some grocery money, because selecting produce confidently is just as important as cooking it well. If you're ready to turn curiosity into skill and skill into joy, I would love to welcome your teen into my kitchen. Parents are most welcome to sit in as chaperones or return at the end to savor their children's culinary creations.